It turns out that the precision in an estimate, the precision of an estimate that we calculate based on a sample, depends on the sample size, but it does not depend on the population size. Let me say that again. The precision of an estimate depends on the sample size, but not on the total number of people in the population, or the number of units in the population, as long as the population is much, much bigger than the sample, which is typically the case for drawing 500 people out of an entire enormous state. So how are we going to think about this? Suppose we have a bowl of soup. Okay, suppose we have a bowl of soup. I'm going to draw a bowl. Here it is. Okay, that's my bowl, and here's my soup. It's got waves in it. Okay, that's my bowl of soup. And I'm going to take a spoonful of soup. There's my spoon. Let's label that because my drawing skills are not necessarily awesome. Okay, I'm going to take a spoonful of soup, and what I'm trying to figure out is whether my soup is salty enough or too salty. I want to assess the saltiness of my soup. I want to estimate the saltiness of my soup. Let's think about what influences my guess at how salty the whole bowl of soup is based on my one spoonful. One thing that matters is whether the soup is mixed well, right? It matters whether the soup is mixed well. Because if the soup is not mixed well, maybe the salty part is over here, right? And there's some big patch of non-saltiness over here, and I'll just dip into that part and I'll say this soup needs more salt, right? But it won't be true. The salt was just down here, right? So how well the soup is mixed makes a difference here. What else? The size of my spoon makes a difference. If I just take a tiny little droplet of soup, I might have trouble assessing how salty it is. If I take a huge dipper full, I might have an easier time assessing how salty my soup is. So the homogeneity, well, the mixedness of my soup matters. The size of my spoon matters. The variability within my soup matters. And what do we mean by that? Suppose that this is a really, what's the word? Choppy sort of soup. So there's all kinds of things floating in my soup, right? These are big pieces of carrots or something, right? And perhaps how salty I think the soup is depends on whether I happen to get one of these big pieces of carrots in my spoon, right? That'll make it harder to get a good estimate of the overall saltiness than if the soup is a puree and every bite is likely to be the same, right? So what are the things that we're saying influence my ability to have a precise estimate of the saltiness of my soup? The size of the spoon, in other words, the amount I taste. How well the soup is mixed, in other words, how representative my sample of soup is going to be. And the homogeneity of my soup. Is all the soup the same, or is there a lot of variability in my soup? What does not matter in terms of my ability to precisely estimate the saltiness of my soup is how big the pot is. As long as the bowl of soup is well stirred, the size of the bowl of soup does not influence my ability to estimate its saltiness. Let's write those things down on a slide just so that you have them. So here's a picture of soup that's better than the picture that I drew on the board. You want to predict the true overall flavor of the soup by taking just a limited number of bites. The accuracy of my prediction depends on how homogeneous the soup is. So is it a puree, or does it have these chickpea bean type things that we see in the picture here? How representative are my bites? In other words, is the soup well stirred? Is it well mixed? And how many bites I take. Similar, how big is the spoon? Right? but it does not depend on the size of the bowl of soup. That's the intuition that I want you to have here. If the soup is mixed well, the amount that I need to taste before deciding whether it needs salt does not depend on the size of the bowl, but rather the variance of my estimate, the precision of my guess at how salty the soup is, depends on how much soup I taste, not the size of the bowl, as long as the population, the bowl, is much bigger than the sample, the spoon. So the way to think about that in our election context is that the state of California or the state of Oklahoma is the population. All the voters there, the potential voters there, are our big soup bowl. They're all in a big soup bowl. And I'm going to take a sample of people and ask them who they're planning to vote for. That's my spoonful. And then I'm going to take those people who I sampled and use them to estimate the overall proportion of people in the state who would vote for, say, the Democrat. So the accuracy of my guess based on the sample depends on how big of a sample I take. If I collect data from only 3 people as opposed to 5,000 people, that'll make a difference. I'll get a better guess at the proportion of people in the state who are going to vote for a particular candidate if I sample 5,000 people instead of 3. Okay, so the sample size, the spoon size matters. It'll depend on how well mixed the bowl is, in other words, how representative my sample is. Did I put all the names of the people in California in a hat and randomly draw some? Or did I just walk up to some people who live next door to me? Is my sample representative of the population? Did I mix the bowl of soup well before I took a spoonful? And then also how homogeneous the values in the population are. If every single person in California was going to vote for the same candidate, then it doesn't matter as much which people I sample. So the accuracy of my guess of who's going to, or who is the favored candidate by the entire state depends on the number of people that I sample, how homogeneous the state is in terms of its voting inclinations, but it does not depend on the entire population size. It doesn't matter whether California has 3.8 million or 38 million people, as long as the sample that I draw is representative. That's the idea here.